Hi, welcome to Unit 1.4b on average atomic mass. Make sure that you write at the top the title and the page number in your notebook. And you also want to make sure you include that in your table of contents. Okay, so in this video we're learning about average atomic mass, and before watching this video you sort of seen another video where average atomic mass are described. So we'll quickly go through the notes here, and then you'll do practice using another video for guided practice. All right, so average atomic mass is the weighted average mass of all the naturally occurring isotopes of a particular element. And it's also the decimal number in the periodic table. So when you look in the periodic table and you see, for example, under the sodium, I can just show you by flipping it around, that's your average atomic mass, that decimal number in the periodic table. Now it's important to note that this is not the same as the mass number, and there are actually three reasons why the mass number and the average atomic mass are not the same. One, the average atomic mass is an weighted average for all the isotopes, the masses of all the isotopes. And the mass number is just represents the mass of a single isotope. The other reason why they're not the same is because the masses of protons and neutrons, which are used to calculate the mass number, are not exactly equal to 1 AMU. They're a little bit more, so it's something like 1.007 or 8 AMU, something like that. And so therefore the mass number is sort of an estimate of what the mass of the atoms are. And then the third reason why this also speaks to the mass number being an estimate is because, remember, electrons, even though they don't contribute much to the mass of the atom, they do actually have a mass. And so when we look at the average atomic mass, there are three reasons why it's not the same as the mass number. One, it's a weighted average. Two, the mass number sort of estimates the mass of the atom by just using the number of protons and neutrons and not including the actual mass of protons and neutrons or the number of the mass of the electrons. Now you don't need to know all those things, but you need to sort of keep that in the back of your mind that they're not the same. Now, even though they're not the same, it is true, though, that the average atomic mass, so that decimal number, will approximately equal the mass number of the most abundant isotope, okay? And it will be close to the mass of that most abundant isotope. And that's has to do with the fact that if you're the most abundant isotope, then you're going to be contributing more to the average atomic mass. Now, since the average atomic mass of sodium is 22.99, the mass number of its most abundant isotope is likely 23. And also the mass of its most abundant isotope will probably be close to this number, right? So you can use, even though they're not the same, you can use the average atomic mass to predict the mass number of the most abundant isotope. All right, if you need more time to copy the information that's in the notes, you can pause the video now. Okay, so how do you calculate the average atomic mass? The first thing you need to do is you need to multiply the mass of each isotope by its relative abundance in decimal form. So a lot of times the abundance is given in percent abundance. You need to convert that to a decimal first, and then multiply that with the mass of the isotope. So for example, if we look at the example in the bottom real quick, my step one, I would take this percent and convert it to decimals by just dividing it by 100. So that becomes 0.6011, and I would multiply it by the mass. I would do the same thing here. I would take 39.89%, convert it to decimal by dividing by 100, and then multiply that with the mass. So it will be 0.3989 times 70.925 AMUs. Okay, once you have the product in step one, so you've multiplied each of those things, you should have several products there, then you're going to add up all the products. So I would add up whatever I got when I multiplied the abundance and the masses. So those are the steps. So if you need more time to copy this information down, do so. Okay, the last thing you're going to do is you're going to follow the examples in the second video that you're going to watch, which the first example, I sort of set up the information as a table as opposed to a word problem. So if you want, you can copy the word problem, or you can copy this information in the table, which says calculate the average atomic mass of gallium, and then I have the isotopes listed on the left, the percent abundance in the middle, and then the mass for each. So if you want, you can pause the video now and copy this information. All right, the last two examples that you're going to follow from the video, the next example, rubidium has two isotopes, rubidium 85, the atomic mass of 84.911 AMU, and rubidium 87, and the atomic mass there is 86.909 AMU. The atomic weight of rubidium is 85.47 AMU, and that you would get from the periodic table. So if you look up rubidium in the periodic table, there you go, you see that average atomic mass. And so which of the two isotopes rubidium is more abundant? Explain. So you would copy that information down and then follow the example in the video. The last example is calculating the average atomic mass of magnesium, and you have the isotopes listed, the mass listed, and the abundance listed. So if you need more time to copy this information down, you can pause the video now for 4B. And if you need more time to copy down the information for 4C, you can go ahead and pause the video now. All right, so then you're going to follow the examples that are done in the last video. Make sure you get those copied into your notes. And that's it for this video. Have a quality day.